So, okay, I think I managed to solve the problem at least, find some project that was not that messed up and could add the American new game strategy and let it fulfill the interface to start with. So something like that, and we will do the same thing for the European version. And let's just copy paste this for now. And the last thing there was to show the card. So basically this is the same code that you have been looking at. The difference is that we send in a player object, and we send in another player object that represents the dealer, and we send in a deck. And now this algorithm is encapsulated in these two types of classes instead, that does the actual dealing of the cards to start a new game. And basically it's the same. Take a card from the deck, show it or not show it, and give it to a player. So the next step is to not let the dealer be abstract anymore. It is a fully functioning class now, and it should have a member variable here. And this could be private again. So we just add a member variable, an attribute that represent this rule of starting a new game. And of course we use the interface type here. If you remember back to the class diagram, we had an association from the client to the interface. So the idea here is that the dealer should not know of the concrete implementations of the different ways of starting the game. Instead, it will just use these rules to start a new round. A player, this, and deck. I also think we need to use something like this. You should only be able to start a new game when you are not playing. So something like this. So the problem now is that we need to have an object here, and who should create this object? We need some object to fill that slot, so to speak. And it needs to be either an American start new game strategy object or a Euro start new game strategy object. So where should we add this creation of this object? Well, we could do something here. Like this. And maybe we should just start by doing this and see that things work. So let's try and compile and see what we got wrong. Public is not valid for this item. All right, you don't need to do that in interfaces. This is an interesting. Need to fix this. Play. Yeah, and we got a visible card here. I should hit on that, of course, and I should hit again, and then I should stand, and I win. So, all right, this was one way of doing it. We could just create the object here up in the constructor. Is that a good idea? No. Why? Yeah, but there is actually a reason for this, that this is not a good idea. If we think about the creator pattern, it says that, well, if the class closely uses the object of another type, it should be responsible for creating it. And this is kind of like, okay, I'm using the rule, so of course I should create it. However, in the strategy pattern, the idea was that the client should not know of these. They should not know of the concrete algorithms. So by adding this new, we actually added a dependency from the client, from the dealer, to the Euro start new game strategy. So we get an arrow here, a dashed arrow to be precise, down to one of the concrete algorithms. So that is not a good idea to add this. We went through all this trouble to shield, to protect the dealer from the concrete rule types, but now we just added a dependency. So someone else should do this. And for now, I think we should just send this in. So someone else outside of the dealer will need to know what rule the dealer should use. It's like the manager that, well, here, take the rule book, and the dealer looks at it and uses those rules. So let's send it in instead. However, now we need to, someone else needs to do something, and right now it's like outside here. Let's start with American this time. You can see that the dealer has a hidden card. I should hit on that, of course, and 12, hit, 19, and stand, win, yay, quit. Did you get this? So we went through the trouble of creating an interface, doing realizations of this interface, but then we just added the concrete algorithm directly into the class that we wanted to be protected from all these changes and variations. And that is obviously not a good choice then. So, okay, but strategy, break out the things, the algorithm that can vary, construct an interface, implement different variations, let the client have an attribute of this type, and use this interface to perform its service. So I think we have the slides here. So this is the structure, and in our case then we'll be needing 3 different interfaces if we are to support 3 types of rule variations. And we will be needing then the number of subclasses or realizations to these. But this will be 3 interfaces, 4 for each, so 3 times 4, that's 12. So in that case, we will have 12 classes instead of 81 classes. So That's a pretty big win. Some consequences of the strategy pattern. Well, we add parameterization of client objects. This is also called dependency injection. We kind of like inject a dependency into the client object. In the dealer in this case, we inject what kind of rule it would like to have. And this is actually just a fancy name for adding parameters to the constructor. So when you hear this, oh, then let's use dependency injection. Basically, it means adding parameters to the constructor. And this has been done since the invention of object-oriented systems. So that is actually nothing new. But fancy names are always fun. And there are some other issues also with dependency injections. You can use different frameworks for creating these objects and stuff like that automatically. Anyway, this is favorization of composition of objects instead of inheritance. And this is something that you can find out more about, and you hear a lot that we should favor composition over inheritance. Inheritance is good in some respects, but it also becomes quite messy, as we saw in this example. If we are supposed to supply more kinds of variation than just this single dimension of the start new game, then inheritance becomes quite complicated. And we have this explosion of combinations in our case. But if we compose our objects instead of inheriting functionality, we can alleviate this problem. Also, we can reuse the rules. So composition also favors reuse in a better way. So if we have the same kind of rule in another game, in another card game, we could take these rules and just reuse them much more easy than if we have 81 combinations of dealer classes to code. Who creates the concrete strategy objects? This is a problem that we need to solve in some way. We need to address this. We, of course, get more classes, especially in this simple case with only one rule variation. Instead of just having an abstract base class and two concrete classes, we get a class and we get an interface, and then we get two realizations of this interface. So this adds some kind of complexity. It's hard to construct good interfaces. In this instance, we kind of like did it as a refactoring. And then we knew, okay, to start a new game, we know these two ways of doing it, and we know then how the interface should look. And this is not something that is always easy to do in advance. You need kind of like detailed knowledge about how this is supposed to work and how this is supposed to be implemented to make good interfaces. So you should probably expect to not get it right if you do this in advance, so to say. So you will probably need to change this interface of the strategy as the design evolves. So that is to be expected. There is always also a risk of circular dependencies. We can see that, well, the dealer has an association to the start new game interface. It contains an attribute of this type, so this is an association. And we can also see that the interface actually uses the dealer and the player and the deck types. So we have dependencies from the interface to these types. So it creates something of a circle here, and circular dependencies are always a little bit messy because things get codependent on each other and get harder to reuse and stuff like that. So constructing this interface in a good way to avoid circular dependencies is quite hard. You will be practicing this strategy pattern in the third workshop, where you will actually continue the implementation of the blackjack game and add the variations for not starting the new game, but when the dealer should hit and when who wins the game. So you will be practicing this a lot. All right, as you saw earlier, we had this problem of who should create stuff. And we then have a couple of patterns, often with factory as the name, abstract factory and factory method. And well, the problem is who should create an object if creator is not a good choice. As we saw in our example, well, creator was not a good choice because that added a dependency from the dealer to the type that we wanted. And factory then says that we should assign the responsibility to an operation in a new class and call it factory. So this is the basically, okay, let's create a factory class, rule factory, for example, in our case, that we can ask for an object. And this could be the case if, for example, we would like to read from a settings file or something like that. What kind of rules should we have in this game? And this could be in this settings file. And there will be a lot of code for parsing this file and stuff. And this should then go into the factory. The abstract factory is about implementing a kind of a factory class to create families of objects. So in some cases you have a family of objects that are related to each other. You can imagine a graphical user interface, for example, on different platforms. You have windows, buttons and checkboxes. And these can be present on a Mac environment, on a Windows 10 environment, and a Linux environment. And your application uses kind of like windows, checkboxes, and buttons. And using the abstract factory pattern, we can let these families of objects vary depending on different things. And factory method is just to use a polymorphic operation to create objects. So in subclasses, we can create objects of different types that fulfill a common interface. And this is exactly as the template method for creation. So let's use the factory pattern instead of doing this from the start of the program. So just add a new class, and this will be plain factory. So this is where the code would go to. To create this rule that we want, for example, reading from a settings file, and this way we can have we can ship different versions of our games much more easily by just adjusting the settings. So we can have a new blackjack game for different markets and so on and so forth. But in this case, we will just return a new object as this is not that important in this class. So we will use a rule factory, and in the program we will, instead of sending in a model like this, we will do public? No. So in this instance, this will look like this instead. And we should be able to run and play. I think we need to actually do some better randomization in this program. Probably the same numbers come up over and over. And we actually had a good discussion about random numbers in the PHP Slack channel. So you can go out and look at that discussion about randomness in computers. It's a fascinating topic. However, something else actually happens here now. Because there is nothing actually right now just, okay, when I'm coding this, well, I don't know how to use the rule factory, and I don't know what that is. I just want to do this. This runs just fine and compiles fine, but we have broken the design. And this is something that happens from time to time. Because when you sit down and code, well, you are rushed, you make mistakes, you don't understand, you don't look at the class diagram, you don't understand the pattern. So you make stupid decisions from time to time. And when I have started to do this, when another programmer comes in and he sees this code, well, he probably looks at it and says, oh, okay, this is the way to do it. So these mistakes kind of like accumulate quite fast. So in our designs, we should, of course, strive to minimize mistakes, make things as robust, and there should only be one way of doing one thing so that you do it the right way or it won't compile. And right now, actually, the concrete classes here could be private, only visible in this package. So we can encapsulate these classes further. They're not visible from the outside. The factory is part of the package and can create them, but from the outside, this will not be possible. So, no, possibly it will be need to be protected. Okay. Someone that is good in C# and knows how to do this? It should be possible to do it anyway. I will take a look at this and see how it is done. So, but at least we can probably increase encapsulation and avoid mistakes like that and not let this be publicly visible outside of this namespace of the rules. But I will check how this is done after the class. So, in the same kind of like way, we can take a look at the controller once more, and we can see that the controller is kind of a little bit messy. It has dependencies to the dealer and to the player, and well, it kind of like shuffles these objects around a lot and gives the player to the dealer and stuff like that. And well, the code is maybe not that messy right now, but we have a way of messing things up here. And also, there is nothing hindering the coder of the controller to just do stuff like this. And this is also a problem. So more couplings from controller into the model. Kind of like you need to know what you're doing when you do mess with the controller. And this is something that is not that nice, I think. Yeah, we should take a look at the abstract factory structure first. This is the abstract factory structure. Obviously, it's trivial. Maybe not. The abstract factory is about, well, you create an interface for creating different types of objects. In this case, we have product A and product B. And you have concrete factories that create instances of different types of products that fulfill a common interface. So the important part here is, well, the client knows about the abstract factory, and he knows about the interfaces to the products. Depending on what concrete factories is done, different types of product families are used. So in this case, the B type of products are used for product B and product A. And, well, we hide the concrete classes. This promotes encapsulation, promotes consistency of objects. There is a lower risk of creating incompatible objects. So, for example, if this concrete product BA absolutely needs a concrete product AA to work, they need to talk to each other in some way. The abstract factory makes sure that, well, you don't pair a concrete product BB with a concrete product BA. So we get a consistent use of objects here. Can be hard to add new products, because if we add a new product interface here, we need to add a new function to create it, and we need to fulfill this function in every concrete factory that we use. So this can be some work. Moving on, how can we protect a subsystem from unwanted changes, access, or dependencies? And then we can use the facade pattern. And the idea of the facade pattern is to design a good-looking single point of contact to the subsystem, a facade. This is exactly the same idea of a facade of a building. So you should always have a nice facade, and the rooms on the inside can be how messy you want, because people will only see the facade and think, well, this is a really nice building, easy to access and use. And behind the scenes, it's messy. So we will use the facade pattern to create a common single point of access to the model. And this is good because if you remember back, we should strive to minimize the dependencies between these architectural components. So if we can do this by adding a facade to the game that removes some coupling and also makes the dealer, the controller, a little bit easier to write and makes it harder to make mistakes, that is a good thing. So let's do this. So basically, we will take a look at the controller and see what it does. He needs to get some hands for and scores that we need to add functions for. He needs to know who has won, and he needs to be able to start a new round and hit and stand. Let's call it starting a round. So something like this, I think, will do it. So basically, Let the facade encapsulate the dealer and the player objects instead. Add functions for getting the values and doing stuff with this collection of objects, and well, basically that's it. And instead of having a dealer and player here, we will send in a game facade. Oh, we need this is game over also. So you can see that the code for creating, starting up stuff becomes easier. Instead of creating a dealer and a player and a rule factory, well, this is encapsulated in the facade now, so we just create the facade and it will manage. The code in the controller at least got a little bit less coupled. So the controller does not know about the dealer and player classes. It just knows that, well, the facade has these functions that I can use to make things happen. And I don't need to worry about how this is implemented inside of this. I don't need to know about at all. So code here got a little bit cleaner, a little less error prone. And we managed to make the dependencies between the controller and model package much cleaner. We have just a single point of access now. However, the facade object, well, in this case, it's not horrendous, but in a more advanced case, it could become quite messy. So in this case, we just have two classes that we kind of like just use to get things done, and this is common in a facade. A facade doesn't really do anything by itself. It just calls other objects to do the work and possibly combines these objects to make things happen. And this would be a great advantage, especially if we have multiple controllers that for different user interfaces, they can all use the same facade and don't need to duplicate this code between the controllers. So this is good. So we have kind of like moved complexity from the controller into the game facade, encapsulated that, and well, we still have the complexity, but it's at least in a controlled place. And this is what the facade does. So the structure is something like this. Well, you have different clients that would like to use some service. This service is possibly implemented by using a number of different classes that are connected to each other in different ways. And the job of the facade is to manage these service classes and make them perform the service needed by the clients. So the clients are kind of like shielded from the stuff that goes on the right side of this diagram and does not need to know about that service class 4 needs a service class 2 to work properly. This is the job of the facade to make this happen. So this is of course better than to let the client 2 have all these dependencies and then client 1 also have all these dependencies to perform the same service. If you remember from the grasp pattern, we had this indirection pattern that was about adding a middleman, so to speak, to manage complexity. And this is exactly an example of that. We add this facade, a middleman to manage the complexity of stuff. So the clients don't really care about what is happening here. They just want this service performed. And this could be anything here. And we can also maybe possibly switch what this is depending on different circumstances. Some consequences. We move complexity from the clients to the facade. And this could be a good thing. Especially in our case, we have this goal of separating the components as much as possible in the architecture. So if we can move complexity from the communication between the controller and the model and put this in a facade instead, that is probably a good thing. However, the complexity doesn't magically disappear. It's still there, it's just better encapsulated. We have cohesion and coupling that we should think about. It is probably better for the client. However, it could be worse in total. In our case, I think it's worse in total because we removed like one dependency from the we removed 2 dependencies from the controller, added the 1 dependency, and we added 2 dependencies from the facade to the player and the dealer. So, well, it's not a big win. And cohesion is always messy in the facade. To have a really cohesive facade can be hard to design. But, well, complexity possibly moved from a bad spot to a good spot. So that is something to think about. We gain encapsulation. No one needs to know now that there are dealers and players. This is handled in the facade. In some cases, we can't get away with just one object or one class to create the facade. Possibly we need to add more classes to, for example, get information from the model in more complex ways. For example, in our case, I think it's a little bit messy with this get hand of player, get hand of dealer, get score of player, get score of dealer. this should maybe be considered at least. And we could maybe add a new type there to encapsulate this information instead of adding several different functions. Facades are quite hard to design if you don't have detailed knowledge about how the clients are supposed to work and how the services do their work. So don't expect a stable facade interface to just be there. It will probably take some time before that happens. I don't think we will go into composite for today. We will leave that for tomorrow. So we have seen now in this code how we can use the strategy pattern to encapsulate rules and offer better combinations to the dealer. We have seen how we can use the factory pattern to handle creation of the concrete rule types so that this is not known from outside. And we have seen how the facade pattern can help us move complexity from the controller into the model instead and make the components a little bit easier to use and more separated. So 3 patterns for today. I think that we will not go continue actually the blackjack game. I think it is more or less done for now or for the course. We have some patterns left, but I haven't seen any real use of them in this application, so we will be doing some smallish test applications just to try them out tomorrow. And we have the composite pattern and the visitor pattern to talk about tomorrow, I think. Any questions? Nothing? It's totally obvious? Probably not. I think that you need to try this stuff out yourself, make small experiments, try the code, see where it is hard, where it is easy. You will be doing this in the third workshop, but your own experiments are always a good thing to do. So I urge you to code and try this out for yourselves. So anyway, that's it for me for today. I think we have lecture tomorrow also. Yeah, good. See you then.